Good morning, everyone. I am Professor Deepa Philip. I am from IIT Kanpur, and today we are here for the second week session of the course titled Artificial Intelligence in Industrial and Management Engineering. This is from the NPTEL MOOCs component of IIT Kanpur, and along with me, Dr. Prabal Pratap Singh is also co-teaching this course. And if you have already gone through the first week and the current lectures of the second week, you know that we have already seen the importance of systems engineering, industrial engineering, and how is industrial engineering different from other engineering, and the basic concepts of AI, why is AI important and how decisions gets made, etc., and what is the importance of data in the decisions, etc. And today, if you look into the slide, we are going to talk about an interesting topic called knowledge representation. Right? And though this is a very prominent and very well researched area in computer science, especially in the AI domain, we are only going to go through what is necessary for us to understand or have a working knowledge about. And you can study deep later into this, but this is like more of a practitioner's knowledge of or practitioner's viewpoint of what is knowledge representation. So, let us start with the importance of knowledge representation. Okay. Why is this critical? That is the first question that we need to do. So, the main reason, I will just say this is like a non-fact. Experience indicated that intelligent systems, okay, and you remember in the course we were talking about this concept of intelligent systems. Intelligent systems cannot achieve anything meaningful, anything, let us say instead of meaningful I will say useful, unless, the keyword is unless, they contain a large amount of real world knowledge. Okay. The key word is real world knowledge. Okay. Or instead of the real world knowledge, I can basically use the other word. I will probably say that you can say probably domain specific. Okay. Knowledge we call as real world, or maybe another way to think about is domain specific knowledge. So, any intelligent system that we talk about at this point, it cannot achieve anything useful unless there is a large amount of real world knowledge is built into it. Now, the second aspect that we need to think about is second thing, humans almost always, okay, or how we do it, tackle difficult real world problems by using their resource of knowledge or resources of knowledge, okay, which are sometimes I can call it as, people call it as experience, okay. Sometimes they call it as training, sometimes people call it as know-how, okay, etc. Okay. So, what we do as human beings is that we solve these real world problems by using our knowledge resources or resources of knowledge, okay, and which we may call colloquially as experience or training or know-how. So, that is how we human beings do it. So, then the question is how knowledge can be represented inside a computer. Why do you want to do this? Why? So that an AI program you can call it as an application also reasonably, program or application can manipulate it, manipulate or use it. Okay. So, human beings, we store it in our brains and we use that to solve the real problem, and how this knowledge can be represented inside a computer. Okay. That is the main question, and why do you want it to represent it? So that an AI program or an application can manipulate or use it. So, now let us talk about the next topic, which is called as knowledge representation. Okay. And there are again, as I said, there is a lot of work goes in this area, but the main ways of doing it is, the first way of doing it is what you call as production rules. That is the first way of doing things. Number one is the production rules. Okay. And then second way of doing it is what we call as formal logic, okay, which is, and languages based on it. Okay. Example, prologue. Okay. So, the formally use the logic or formally represent the logic, or using a language like prologue who can do that. And then the third one is what you call as structured objects. We are not going to go through all of these, but these are different ways you can do it. Okay. And of the structured objects, you have one called as semantic nets, or networks. Okay, semantic networks. Okay. Then B, frames and object oriented programming, which was derived from frames. Okay. Then you can say other similar objects like scripts. Okay. So, the structured objects, these three, which is the semantic nets or frames and object oriented programming, or scripts, similar objects like this one is scripts. These are the three structured objects through which you can also represent knowledge. Okay. And so, there are other options also, but this is the broadly one that is required for us. Now, let us talk about knowledge and experts. Okay. How knowledge and experts happen as part of it. So, there are many ways or many things, many definitions that happens of it. So, let us talk about what is knowledge to begin with. How do we define knowledge, okay, for this purpose of the course. So, we can call it as it's a theoretical or practical, does not matter, okay, understanding. It's a theoretical or a practical understanding of a subject or a domain. Okay. So, we simply define knowledge for this course as a theoretical or practical understanding of just a subject, or it can be a domain. A subject, you can talk about it as like structural engineering or whatever it is, but a domain you can talk about as civil engineering as an aspect of it. Okay. So, it can be either theoretical or it can be practical understanding. Okay. Then you should also think about in another way is, it is what is knowledge is, it is also the sum of what is currently known. Okay. So, whatever you have, whatever you know and whatever you keep on gaining to know, currently know, it will keep on adding and it's kind of an additive in nature. So, it keeps on adding the sum total of whatever is currently known, and we also know knowledge is power, right. We all know the saying. Okay. fine. Then now let us call as experts. Okay. Who are experts? Many definitions to it. So, the simplest definition is that I will use this in course is those who possesses or those who possess knowledge are called experts. Okay. So, the simple definition here is those who possess knowledge, we call them as experts. Now, when does one becomes or considered as a domain expert? Okay. This is one critical question for us. Okay. When does one becomes or considered as a domain expert? If the person has deep knowledge, okay. So, deep knowledge is a word that I want to expand, both facts and rules, okay. Has deep knowledge of both facts and rules and strong practical experience, in a particular domain. Okay. So, the two critical aspects that is required in this case for a person is it has deep knowledge of both facts and rules and strong practical experience. So, these are the two key aspects, combined aspects that makes the person or that makes us to consider that the person has is a expert. Okay. Now, the other thing is you should also understand, please note, okay. This is critical to note this. Okay. Area of the domain may be limited. Okay. So, an example of this is you can say domain aerospace, area aerostructures. So, the person might be an expert, domain expert in the area of aerostructures, not for the entire domain of aerospace. So, that should also be considered as part of this. Now, let us go back to, in simple terms, expert is a skillful person, who can do things other people cannot, that other people cannot. Okay. Why other people cannot do this? Because other people does not have the deep knowledge of both facts and rules and strong practical experience. So, that is the other way to think about an expert. The skillful person, the skill comes from the practical experience, it is hands on experience and have the deep knowledge. But remember, the domain expertise can be or most of the time will be very well limited. Now, let us talk about another key term as part of this, which is called as long term and short term memory. Okay. And this is critical, because what we are going to now discuss about is the production system model, important to production system model. Okay. So, if you remember, the production system model is one of the ways how knowledge is represented. Okay. So, proposed by, it is Newell and Simon, okay, and it was in early 70s, I believe 60s and 70s. Okay. So, it is the other one is the, it is also the foundation or basis of the modern rule based expert systems. Okay. We have in previous courses also seen decision support systems, expert systems, etc. So, the production system model which is proposed by Newell and Simon forms the basis or the foundation of the modern rule based expert systems. So, the idea of production model or production system model. What is the idea of the production system model? Okay. So, the idea is that humans solve problem or solve problems, multiple problems by applying their knowledge, This knowledge is expressed as production rules. To a given problem. So, humans solve problems by applying knowledge to a given problem. Okay. So, this another way to think about it is problem specific information. Okay. So, it is called as the problem specific information. So, the humans solve problem by applying their knowledge which is expressed in the case as production rules to a given problem, okay, or what we call as a problem specific information. And the other part is the thing also should do is the production rules. What is production rules? Production rules is the knowledge. Production rules are stored in long term memory. Okay. They are stored in long term memory. Remember that. Okay. Production rules are stored in long term memory. And the other one is the problem specific information. Okay, or facts are stored in the short term memory. Okay. So, for example is the knowledge. So, an example is knowledge would be V is equal to IR, voltage is equal to current times resistance. So, the fact, this is an example. Okay. The fact would be the required ohms for a particular circuit. Okay. That is very specific, very problem specific. I want a particular circuit for which I need a specific resistance. Okay. But the relationship of resistance is between, it is a ratio between voltage and current, which can be, which is what we call as a knowledge. Okay. I can see that from this. So, for a better understanding, I would schematically represent the production system model as this way. Okay. You have what you call as production rule or rules, and you have something called as facts. Okay. And we create a reasoning. Okay. The reasoning uses both, okay, production specific rules and other things, and from there we create what we call as conclusion. Okay. Now, the important thing here is that this is the production rules, this forms the long term memory. So, the long term memory is the production rules, which is the knowledge in another way, and facts is in the short term memory. Okay. So, this means this is problem specific information. This is specific to a problem, whereas this case it is knowledge. Okay. So, the knowledge gets stored as production rules in the long term memory, whereas the facts get stored in the short term memory or problem specific information. Combine them together with reasoning, you reach what we call as the conclusion, right. So, okay. Now, let us talk about rules. Okay. That is we use rules as a knowledge representation technique. We talked about production rules. Okay. So, rule in AI, okay. Just look at in the simplest way. Okay. Most commonly used type of knowledge representation. Okay. It is most commonly used type of knowledge representation. Can be defined as an if then structure. Okay. What does this if then structure do? It relates given information or facts in the if part to some action in the then part. Okay. So, it can be defined as an if then structure, where the information or facts are in the if part and the some action is part of the then part. Okay. Another one is, now let us talk about some other things. A rule provides some description of how to solve a problem. Okay. How can you solve a problem, or how to some roadmap of how to solve a problem is provided by the rule. Okay. Then rules are usually easy to create and understand. Okay. It is usually easy to create and understand, that is another aspect. Okay. It is easy to create and understand. So, now the third one is any rule consists of two parts. Okay. A, the if part, okay, known as antecedent. Okay. The if part, which is known as antecedent is also can also be known as premise or condition. Some people call it as condition, some people call it as premise, but it is known as the antecedent. Okay. B, the then part, known as consequent, okay, also known as conclusion or action. So, two parts, the if part which is known as the antecedent, which is the premise or also known as premise or the condition, and the then part which is known as the consequent, which is called as the conclusion or action part of it. So, continuing on to this, let us think about a couple more things. Human mental process is internal, okay, and too complex to be represented as an algorithm. Okay. So, it is the human mental process is too complex and it is very difficult to represent it as an algorithm. Okay. However, most experts can express parts of their knowledge in the form of rules for problem solving. Though the human internal mental process is too complex and cannot be represented as an algorithm, most experts are capable of expressing parts of their knowledge in the form of rules for solving that problem. So, let us take an example. If the simple example, the traffic light is green, okay, then the action is to go. So, this is a simple way of writing a law or a rule, is that if the traffic light is green, the action is to go. Okay. Other option is if the traffic light is red, then the action is to stop. Okay. So, you can see these are two kind of rules where this if, this is what we call as the antecedent part of it, and this is the action or the consequent part of it. Okay. So, both rules have the if and the action part as part of it. So, now we will continue just looking into this little bit more, and with this we will come to a conclusion of this today's lecture. So, let us say first thing is antecedent of a rule has two parts. The antecedent of any rule has two parts. Part A, okay, an object, okay, and then part B, its value, and then the object and its value are linked by an operator, Okay. So, antecedent of a rule has two parts. The first part, part A, is an object, part B is its value, and the object and the value are linked by an operator. So, other part is operator identifies the object and assigns values. Okay. So, it identifies the object and assigns the value. Okay. Example, okay, is, are, is not, are not. These are examples of the operators in this regard. Now, one more thing is expert systems can also use mathematical operators to define an object. As numerical and assign a value and assign it to a numerical value. Okay. So, you can use mathematical operators also. It does not have to be these operators, what I said earlier, you can also call it as linguistic operators. Okay. But you can have a mathematical operators also. An example is if age of customer, okay, is less than 18, okay, and cash withdrawal is greater than 2000, then parent signature is required. So, you can see this are the mathematical operators. Okay. So, this probably would give us an overview of how the rule and the two parts of the rule, how it is production rules which is represented as if then and the antecedent and the consequent part of it, and how the antecedent has two parts which is object and a value, and how an operator links the object to the value, and what are the linguistic operator and what is a mathematical operator. Both aspects we also see that, and we can also see that it does not have to be a linguistic value, it can also be a numerical value as well. Okay. With this, we come to the conclusion of this particular lecture, and we will complete the very small lecture of the production rules, and before we get into other forms of knowledge representation and a simple example of what is an expert system. Now, if you look into it, so how do the rules, okay, production rules for relations, recommendations, directives, strategies and heuristics. Okay. So, we said that there is this if and else, if and then, which is the the antecedent and the also what we call as the action part of it. So, now let us look into these multiple ways of what it is. So, let me start with what we call as a relation. Okay. The first one is the relation. Okay. What is a relation? An example of a relation is if the mass is m and acceleration is a, then the force is m times a. So, if the mass is m, acceleration is a, then the force is m times a. So, this is an example of a relation, how relation can be represented as a production rule. Now, let us talk about the second one, which is, so we are not done with relation, now we will talk about recommendation. So, recommendation. Okay. How recommendation happens? If the month is August, like this month, and the sky is cloudy and the forecast is rain, then the advice is take an umbrella. Okay. So, you can see that the recommendation where the month is August, then the sky is cloudy and the forecast is rain, then the advice is to take an umbrella. So, this is the second one. Now, let us talk about the third one, which is the directive. Okay. So, let us talk about directive. Okay. So, what is a directive? An example of it is if the car is dead and the fuel tank is empty, then the action is refuel the car. Okay. So, this becomes an example of a directive. Okay. So, we have seen what is a recommendation. Recommendation is in the form of something that you recommend, the advice is to take an umbrella, and the directive we have seen is also it is in the form of what you need to do if you come across two conditions. Okay. Now, continuing this, we also talked about something called as what is as a strategy. So, what is a strategy? Okay. So, let us write strategy. Okay. What is a strategy in this? Okay. So, if the car is dead, then the action is check the fuel tank. Okay. Then use fuel rules. Okay. So, this is a strategy. If the car is dead, you check the fuel tank and then based on which use the fuel rules. This is an example of a what we call as a strategy. Now, let us talk about something called a heuristic, as we mentioned in the previous slide. Okay. So, last part, the fifth one is the heuristic. Okay. So, heuristic, what is a heuristic? So, let us take a simple example. If the spill is liquid, okay, and the pH, okay, is less than 6 and the spill smell is vinegar, then the spill material is acetic acid. Is an example of a heuristic. Okay. So, if the spill is liquid, the pH is less than 6 and it smells like vinegar, then the spill material is acetic acid. Okay. So, this is an example of a heuristic. Heuristic means it is a rule, it is just a informal way of putting rules in. So, let us talk about a case study now, okay, and this is very interesting case study and I am expecting you to do lot of research on this. So, it is called MYCIN, okay, and what is MYCIN? MYCIN, okay, an early expert system, okay, in 1970s. Okay. The next one is the aim of this expert system or goal, okay, diagnose bacterial infections and recommend appropriate antibiotic treatments. Okay. So, that is the goal of this. Okay. Uh, how did it work? Okay. Used a rule based system, containing around 600 rules. Okay. These rules encoded the knowledge, and decision making logic of infectious disease experts. Okay, infectious disease experts. So then other one is MYCIN employed a backward chaining inference engine. Okay. It used a backward chaining inference engine. Okay. So, what is backward chaining? We will probably do a small example in the class depending on the time. It is an approach that starts with a hypothesis. Okay. And then search for evidence. Okay. Why do you want the evidence? To support or refute the hypothesis. Okay. And all according to the rules in the knowledge base. Okay. So, backward chaining is the approach starts with a hypothesis. In this case, the hypothesis would be a specific example, specific bacterial infection. So, it is like E. coli infection, whatever it is. Then search for evidence. Okay. So, that will be example, will be symptoms, test results, etc. Okay. And using those, the evidence is either to support the hypothesis or refute the hypothesis, and all according to the rules in the system, rules in the knowledge base. Okay. This was not very popular, not very popular in a sense, it was not very widely used because of the fear of regulation and all those kind of things. But nevertheless, this was a very good example of how rule based expert system was built. It was very old 1970s, and even with the computation power being so low and other kind of things, we do not have the fancy computers like we have today in that time period, but they were able to build one system with the limited resources. So, it is imperative that we take a look into it. So, this week course, when week's lecture concludes by this study, I would request all of you to read through the MYCIN in globally available stuff, and we will share an example of the MYCIN case study for you guys to read and understand, and then that will be something that you will all do as part of your individual study. So, thank you very much for your patient hearing. This concludes the production rule based knowledge representation aspect of the lecture. We will come with the other things. We will briefly glance through other things quickly, and we will continue in the third week into more advanced topics. Thank you very much.